Hello again. We are back looking at the limit of a function, and we have just gone through this example looking at how a function f of x equals x cubed minus 8 over x minus 2, how that behaved as the x values got closer and closer to 2. And we saw that as our x values got closer and closer to 2, either with values that were a little bigger than 2 or values that were a little smaller than 2, coming in from either direction there, the f of x values got closer and closer to 12. So we concluded that as x approaches 2, f of x approaches 12. All right, so what that means, or the definition that's wrapped up in all of this, is right down here. We say for a function f of x that is defined when x is near the value c, okay, we say the limits of f of x, limit of that function as x approaches c, all right, so x is approaching this value c, this limit equals capital L, all right, capital L for limit, if the function values f of x gets close to L as x gets close to c from both sides. Okay, so we say the limit of f of x as x approaches c equals L if f of x gets close to L as x gets close to c from both sides. All right, so that's a bit of a mouthful of a sentence there. In mathematical notation, we condense that down quite a lot into a little expression that looks like this. All right, the limit of f of x, so we write LIM for limit, and I do it in cursive because that's the way I learned it when I was in school. Some people will write this in print. It's just the letters LIM. All right. So the limit of our function f of x, leave a little space down here because we put as x approaches c, so x with the little arrow towards c, that's showing x going towards c. All right, this limit equals L. Okay, so we read this notation as saying the limit as x approaches c of f of x equals L. All right, or you could say it literally the way it's written in that definition. The limit of f of x as x approaches c equals L. Okay, so that is the definition and the notation. And we can see the different parts of the sentence in our notation here. F of x getting close to L. That means the f of x values, the y values, start getting closer and closer, going towards some number L. Okay. As x gets close to c, so that's the little x arrow towards c part. X is going towards c, f of x is going towards L on our function. Okay. Now you might say that still sounds a little wishy-washy, like what does it mean to get close to a number? How close do we have to get? And those are good questions. They're covered in section 2.3, which we're going to look at a little later on. It gets pretty technical in there. But for now, just know that getting close to a value, we can just pick numbers that are reasonably close. All right, like we were doing in our example. Speaking of that example, what were we finding in that previous example? Well, we were actually finding one of these limits, okay? In our previous example, the function f of x was that x cubed minus 8 over x minus 2. All right, and we were seeing what happened as our x values were getting really, really close to 2. So we were letting x approach 2. And our conclusion that we found were that the y values, or f of x values, were getting really, really close to 12. Okay, so f of x was going towards 12. So if we take those 3 facts that we saw in the example and put them into that limit notation, we're going to have a limit statement. All right, what we found was that the limit as x approaches 2 of x cubed minus 8 over x minus 2, that limit equaled 12. All right, so that's what we had found. We didn't even know it. All right, in the next video, we'll take a look at some quick limits with graphs.